Tom wants to make a timber frame to hold 15 snooker balls. The frame is to be in the shape of an equilateral triangle, such as PQR in the diagram. Each ball is 52.5 millimeters in diameter. Find the distance between S and T. Okay, this is the easy part of the question. The distance between S and T is made up of these diameters. This is 52.5, here's another 52.5. And then we have the radius of a ball, and we have another radius here. Now we don't have to calculate the radius, because if we put this radius together with this radius here, we have the diameter of a ball, which is 52.5. So the distance between S and T is 4 times 52.5. So we 4 multiplied by 52.5, that's 210, and that's in millimeters. Next we want the distance between Q and S. That's this distance here. So I'll draw out this little dotted triangle. Now, this is actually a right angle triangle. I'll just explain why. Well, it's pretty clear from the diagram that it has a right angle, but I'll just go back to one of the theorems that was covered earlier. We can think of this side of the triangle as being a tangent to this circle. It touches this circle at just one point, this point S. And we know from a theorem that a line drawn from the center of a circle to the point of contact of the tangent to the circle is perpendicular to the tangent. So that's how we know that it's a right angle triangle. Well, it looks like a right angle triangle anyway. Now, what is the distance from here to here in this right angle triangle? Well, it's just the radius of one of the balls, so it's just half of 52.5. so divide this by 2 and we get 26.25. Now we want to find the distance between Q, which is this point, and S, which is this point here. I'll call this distance X. Now we have a right angle triangle and we have one side. If we have an angle, we can find this distance. So we can actually find this angle here. How do we find this angle? Well, we are given that the triangle is an equilateral triangle. And from a previous video, you know that the three angles in an equilateral triangle are the same. And of course they sum to 180 degrees. So each angle must be 60 degrees. So this angle here is 60 degrees. Now, the angle in this triangle is half of 60 degrees, which is 30 degrees. Now, that may be fairly clear from the picture, but again we can use some theorems to prove it. Let's look at a line drawn from the center of this circle to the point of contact of this tangent to this circle. Now we know from a theorem that I just mentioned earlier actually, that the line from the center to the point of contact of the tangent to the circle is perpendicular to the tangent. So basically the length of this line is the distance of this point to the tangent, and that distance is equal to the radius of the circle. I'll just write R there. But of course the length of this line here, which is R, is also the distance of this point to this line. Now a point that is equidistant from the two arms of an angle, of the 60 degree angle, must be on the bisector of that angle. So that's the converse of a theorem that we proved earlier actually. We proved that any point on the bisector of an angle is equidistant from the two arms. The converse of it says that if a point is equidistant from the two arms of the angle, as this point is, its distance is the same, it's equal to R, which is 26.25, then the point must be on the bisector of this angle. So this dotted line bisects 60 degrees, so the angle in here must be 30 degrees. So this angle in here is 30 degrees. But anyway, you don't have to state any of those theorems, you can just see for yourself, you know, just by looking at it, that certainly by the symmetry of the picture, this angle is 30 degrees. Okay, now we have enough information to find X. So what do we need to do? We need to use one of the ratios for right angle triangles that bring in the side that we have, which is 26.25, and the side we're looking for, which is x. So the side that we have is opposite 30 degrees. The side we're looking for is adjacent to 30 degrees. So we need a ratio that brings in the side opposite and the side adjacent to 30 degrees, and that's the tan of 30 degrees. The tan of 30 degrees is opposite, which is 26.25, divided by the adjacent, which is x. Opposite over adjacent. Now, we solve this for x. You know, if we cross multiply, we get x tan 30 equals 26.25 times 1. And then we divide to get x equals 26.25 divided by the tan of 30. Basically, you just have to interchange these two. Replace tan 30 with x and replace x with tan 30, and we get this. So we have to divide here. So we have to take 26.25 and divide it by the tan of 30. So there's the answer. I'll write this down to 2 decimal places. It is 45.47. And this is in millimeters. Now we can find one side of this wooden frame. We just add these three numbers together. Now I've rounded this to 2 decimal places, but I'll work with this value here. It's more accurate. We have 2 lots of these, because it's the same over here, of course. The distance between T and R is the same as the distance between Q and S by symmetry. So I need to multiply this number by 2 and add on 210. So here is the length of one side of this equilateral triangle. So now we multiply this by 3 to get the length of the 3 sides. I'll write this down to 3 decimal places, 902.798. Now, we want to allow for 10% wastage in cutting out. So I will let x equal the length of wood required. Then wastage will be 10% of x. That's 0.1 times x. So then, what's the length of the frame going to be? X is the length of wood required, but we want to subtract out the wastage. So we want to take x, whatever it is, subtract the wastage, which is 0.1x, and that will give us the length of the frame, which we have here. Well, 1x minus 0.1x is 0.9x, and that must equal 902.798. So we need to do this division, and I've already got this number in, so I won't change it. It's the most accurate version of it, so I'll divide by 0.9. So this is how much wood we need. So I'll write this down to 2 decimal places. So it's going to be 1003.11 millimeters.